Mbona sioni watu wanamoja kuadmitiwa? So I want us to do a topic called linear propagation of light. Like linear propagation of light. So like linear propagation of light, I want us to deal with light mwangaza. So light first. Like linear propagation of light. Let's see. Our topic of the day is propagation of light. Linear propagation of light. That's what I want us to deal with. Like the linear propagation of what? Like linear propagation of light. Oh, this you have not covered this. So I think it will be very hard for you as per now, because I've seen there are so many people who are absent. We might be forced not to. Yeah, but actually, yeah, it's okay. Like linear propagation of light. Let's deal with that topic. I've seen it's possible for us to do it. It is a Form 1 topic, so it's a form of revision. So no one will be affected negatively. So like linear propagation of light, one condition, or under one rule, it says that is what we operate under is we say that light travels in line. That is what we operate under this. It's very strict rule that light travels under straight or in a straight line. That is, it gives us the reason why we, in most cases, find, in all cases actually, you'll find that there is formation of shadows. Why do we have shadows? Because the light cannot bend. Actually, it's supposed to travel in a straight line. So when light comes to a barrier, across a barrier, or comes into contact with a barrier, since the light cannot bend, it will just form a shade. Transparent material. So this idea of light traveling in a straight line is the one that is guiding us all through this topic. So every time that's or either eclipse, such eclipse, they are formed because there's no shadows and so on and so forth. So, through the light always travel having any point. Okay? So this topic starts at this point. The manga by sources of light. Sources of light. Sources light. Sources of light. Good. Sources of light. Sources of light. So some objects produce their own light. Luminous sources. Examples of luminous sources. Any object you know that produces its own light. I get examples of luminous sources of light. Anybody? Any luminous source of light? Ryan Kim?
The sun.
Ryan Kim, no. The sun.
Yeah, the sun.
Any other person? The sun? Any other person? Kiprotich. Luminous sources. Imesema yako imesema. Gani? Stars.
Kuna stars.
Sorry? Umesema gani? Kiprotich? Stars. Yeah, stars ziko hapo. We go to who? Jack Mutuma?
Yes.
Any other source of light, you know? A luminous source? They have luminous sources. They have luminous sources. Examples we have said. The luminous sources, we have examples like sun. Unaandika hiyo stars. We have sun, we have stars. We have burning candles. Fire, wood or charcoal fire. Wood or charcoal fire, that's a source of nini. Red hot heating elements. Red hot heating elements. Unasikia Shem? We also have lighting bulbs. Of course, you can see one around you. A lighting bulb. A bulb of course. Light. Yes, television screens. We also have glow worms. Glow. Ushaona those worms that glow at night? Ama mtokangi nje usiku. Nini waoga? Those people who are able to. I'm not talking about night walkers. Night walkers. Those people who move out at night at some point. they normally see those glowworms. See ati ukiona unapotea. You know, some people are very cowards. If they see something glowing, anadhani ni shetani ama ni mtu wako hapo, they just run away. So they are glowworms, they are harmless. They are just luminous sources of light. Okay? Plus any other. Plus many other. There are so many others. Another one. And the other source of light is called non-luminous sources. Non-luminous sources. Non-luminous. Non-luminous sources. Non-luminous sources, they don't produce their own light. They depend on light falling on them from luminous sources. So they purely depend on luminous sources. So when the light fall on them, Ted ameinua mkono. Ted inua mkono tena nikuona. I think you want to mention non-luminous sources. Ted. Ted, you have something you want to say? You have a question? Okay, come on. Ted. Cornelius. Okay. So I think, okay, we can produce, okay, lights, some bodies can produce their own lights, others depend on luminous sources. So I want to mention some examples of non-luminous sources. Any examples you know? We have the moon. We have the moon, right? Moon. That's the most famous non-luminous source of light. Number one is the moon. Number two, we have planets. There are some plants which produce, which reflect light. We have some people. Some people are non-luminous sources of light. Others can allow me to use this. Some people can reflect light, others cannot. Yeah, if you can reflect light, you are a non-luminous source of light. And you can as well be a good absorber of light. If you are dark, a little African, you are a good absorber of radiant heat and light, which is okay. The true Africans, you know them. Yeah, we are there. So some of us produce and luminous sources of light. They can reflect, others cannot. So that's diversity. You find others are this, others are like this. And that, okay. So there are some people who can reflect. There are some books, walls, clothes, wall charts. You can mention anything that can reflect light. It's an luminous source of light. That light appears to be coming from that object, but actually the object cannot produce any light. So, okay. I know you have so many other examples, but for now, let's go to something else called rays and beams of light. Rays and beams of light. Rays, Andika, rays and beams of light. Rays and beams of light. Rays and beams of light. Andika rays and beams. Rays and beams. Rays and beams of light. So we need to differentiate between a ray and a beam. Serious? Rays and beams of light. So the first thing to understand, a source of light produces passes of energy which spread out in all directions. Like when you look at sunlight or sun in the morning, very early in the morning, you can see those rays from the sun. They produce light in pulses of energy which spread out in all directions. Like a bulb, it has got pulses of energy which spread out in all directions. Now, the path along which light energy travels is referred to as a what? Array of light. So let's start by defining array. Array of light. Ray. What is array of light? Ray of light. Array is the path. Is the path along which array of light is the path along which light energy travels. Path along which light energy travels. Very good. That is what we call array. Okay. When rays of light come together, they form a beam of light. So combination of several rays, when we combine several rays, we get a what? We get a beam of light. So a beam is a stream of light energy. Tuandike beam. Andika beam. Beam. A beam is a stream of light energy, which is considered to be a bundle of rays of light. It's a stream of light energy. A stream of light energy is a stream of light energy, which is considered to be a bundle of rays. Brackets, bundle of rays. Bundle of rays. A bundle of rays, like that. So when, supposed to be bundle of rays. I need to undo that. I said a beam. Let me just write another one. That one has been interfered with. Beam. We have said a beam is a bundle. It's a stream. You can say it's a stream of light energy. Into brackets, a bundle of light, a bundle of light energy. A bundle of rays. Bundle of rays. So this is what I wanted you to understand, that this is a bundle of rays. Rays, that means when you bring so many rays together, you form a what? You form a beam. When you bring so many rays together, you form a beam. So there are types of beams of light. Types of beams. Quickly, types of beams of light. We have several types of beams. Na hiyo mtaniambia saa hii. Types of beams of light. I want somebody to tell us how many types of beams do we have. Somebody should mention, the other one should explain what the meaning of that. So we have types of beams. Types of beams of light. How many types of beams? Okay, which one do you know? Anybody? Types of beams of light. Types of beams. Lewis. Lewis.
Yes.
Which type do you know of beam? Of any beam? You know?
Divergent.
Divergent. How do they behave?
They are from a point and then they diverge in all in different directions.
Good. So they are assumed to come from a point, then they're diverging in so many directions. Like for
Yes.
example, I want to draw a few here. Divergent behavior. They behave like this. They appear to come from a common point, then they go diverging like that. So, yeah. Very good. Any other person? The second type? Shame. Shame. I want shame. Not nani. Shame. Shame umepotea. I wanted to unmute you. I've unmuted the wrong person. Okay, shame nimekupata. Shame. Tell us. Huh? Can't hear you. Network yako imeleta shida ama imehang. Kamwaro, give us a type of beams, any type of beams, you know. Alex Kamau. But let's go to Masimbo. We can use Masimbo. Masimbo. Any type of beam, you know?
Convergent beams.
Good. Convergent, how do they behave?
They move towards a point.
They move towards a common point,
Yes.
Like this. And remember, there's something I want you to remind you before you proceed. Anytime you're talking about array, any ray, it must have an arrow. There's no array without an arrow. So that's why actually I want to put the arrows right now. Because if you put array without an arrow, that cannot be called array. It must have an arrow. It must be having an arrow. Like that. So you should not have any array without an arrow. Actually, I'll have to draw others so that you don't get confused. Anytime you're talking about array, there must be an arrow. These are divergent rays like this. So nikiona mtu amechora array bila arrow, tutakosana. That's wrong. Hatapata kitu. Those are divergent. Convergent rays behaves like this. Those are convergent rays. The third one and the last. Wanasemanga last but not least. Ni gani? Tuchague nani sasa? Is this Chege Joroge ama ni yeah? Who can tell us, give us that? Kimutai tuambie, give us that type of beams. That type? Yeah. That type. That type is parallel beams. I can see people. Okay, somebody. There are some people. So many people. Ephraim.
Parallel beams, they move parallel towards each other.
Yeah, very good. They move parallel towards each other. So those are the three types of beams. I'm trying to draw the last parallel ones. They move parallel to each other like this. So they don't meet. They don't meet. They do not meet. So I want to undo that. They don't meet. Parallels never meet. Actually, that is not the main point. This is what I want us to really understand. There are types of beams. Okay, those are the types of beams. The last, or the other part, before we go to point source and there's point source of light and the other type of light that we normally have. So we have extended source and point source of light. Before we go to point source and extended source of light, we have what we call opaque, translucent, and transparent objects. Hiyo hata siandiki. I want somebody to tell me what is an opaque, mwingine translucent, mwingine. I want three people. I want to tell me what's an opaque object, the other one what's an translucent object, and then transparent object. Hiyo hata siandiki mahali. Mtu aniambie, what is opaque? Are you opaque? Are you transparent? Or are you translucent? Yourself. Hebu utaniambia. Kuna mtu transparent hapa? Labda kuna mtu transparent na hatujui. Naona Emmanuel ameinua mkono. Anataka kutupatia gani? Emmanuel? Hiyo naona kuna shida ya network hapo. Jesse?
Okay.
Raise up your voice. Jesse? Ama ni Jesse?
An opaque object.
Opaque
is an object that
what?
does not allow light to pass through.
That's an opaque. Yeah.
An object
Any example?
that does not allow light to pass through.
Any example of an opaque object? They do not allow light to pass through them. Any example? Si useme wewe. Hey, you are opaque. Ama uko transparent? Wood. Yes. Start with yourself.
No.
Start with yourself, bwana.
Me.
Yeah, me. You start with me. Then after me, kutoka tunaenda kwa Emmanuel. That's very good, eh? Very good. Emmanuel, enda kwa choose another one. Either translucent or transparent. Any example? Allah, IG translucent and Jack Mutua. Jack Mutua?
Which translucent?
Translucent, Those are objects
which the light passes through, but you cannot see through.
Yeah, they allow light to pass through them, but you cannot see through them. An example?
Yes.
We have glass panes.
Yes, glass.
Mm-hmm.
Uh, the bathroom glasses. Yes.
Very good. Bathroom glasses. Oh, yeah, glass panes for the toilet and bathrooms, and some windows. Yeah. Of course, you cannot. You don't like to go to a bathroom or even a toilet where the glass is transparent. No one would like to do that. Nama kunai hapa. You can only choose to go to a bathroom where the glasses used are translucent. But you cannot choose the one that is transparent. You cannot. Is transparent. Transparent. I want to select who? Jackson. Jack Kitonga. Kitonga. Jack Kitonga.
These are objects that allow light to pass through them completely.
They allow light to pass through them, and we can also see through them.
Yes.
Examples?
Most window panes.
With screens of vehicles. Any other? Ordinary window panes. Kama hizi za shule. Ama hata the ordinary ones. The ones that can allow light and you can see through them. Okay? And any other. So, let's go to now like linear propagation of light. That was the part of introduction. So let's go to like linear propagation of light. What's the meaning of like linear propagation of light? So we now go deep into that concept of like linear propagation of light. I want to do this. I want to clear this. I hope you're done with this. I want to clear it. I want to clear that. Good. So we have different sources of light. And if you're told what is the meaning of this like linear propagation of light, you're supposed to say that light, it operates under one concept, that light travels in a straight line. We'll keep repeating that all through this topic. Hatutabadilisha. So we have types of sources of light. We have point source of light. And before we go to point source, there is something here. If you're told, if you're given, there's a very unapata kuna some kind of cardboards that are used here. Cardboards fulani hapo zinatumika hapo. I'm hoping sijui kama nitaweza kuchora hapa. Hope I'll be able to. Those cardboards, the holes that are made are supposed to make a straight line. Kristo inakaa kweli, hapana, bado imeinama, lakini elewa tu. So the other one is like this. So true. But if you Chris here, who is at this point, if your eye is here, you close them, you cannot be able to. Why? Because light travels in a straight line. Okay? That property is known as like linear propagation of light. That property is known as light travels in a straight line. Alafu uandike that property, that is known as like linear propagation of light. That property is known as rectilinear propagation of what? We normally talk about call types of shadows formed depending two types of sources of light. You have point source and extended source of light. Okay, there's shadow formation by an extended source and shadow formation by a point source. So nataka uandike hapa shadow formation by a point source of light. You need to understand or differentiate between point source and extended source of light. So nataka uandike shadow formation shadow formation by shadow formation by a point source. Shadow formation by a point source of light. So what's the difference? What's the difference between a point source? Jack Mutua. Jack Mutua. Jack Mutua, you're saying something? Jack Mutua ni kama amepotea wapi? Jack Mutua, inua mkono nikuone. Jack Mutua is saying something, I think. Nimeona mkono ya Jack Mutua ama amenua by mistake. If you have a question, feel free to raise your hand and I can address the question anytime. So point source and extended source. This is a very important concept. Hii itakusaidia sana. Point source. What is a point source of light? What's a point source of light? So this is what I want us to do. You have a bulb here or a source of light here. Sorry. You'd have this kind of a source of light. I have a source of light here. That's a source of light. I want to enclose it in a certain what? I want to enclose that source of light. I want to enclose it like this. Then I don't know how. I'll make a very small hole. Yeah. I'll make a very small hole here. A very small hole here. Naona pale kuna kashimo hapo. So that only a few 2 rays can get out of that place. Only 2 rays. Naona kashimo. Then I want to have a body here. I want to have an object. Whichever color. Can select any color of an object. An object here. The object is here. An object is here. Can you see my object? That's my object. So for a point source of light, only 2 rays. I'm going to operate with only 2 rays. Then I want to have a screen. A screen here. A screen. I'll have a screen here. I can give it this color. This is my screen. So that's my screen. And just bend it a little bit. Ah, good. That's my screen. So that's the object. This is my pin. This pin is my object obstacle pin. That's the obstacle pin. So we'll be having a source of light here. One ray will be going direct. One ray will be going direct like this. And we say there's no ray without an arrow. There's no ray without an arrow. So it will hit the object, the screen like this. That is the first ray. Will hit the screen. We have only 2 rays for a point source of light. Remember that. So those rays will hit the screen like this. But now the screen has got some allowance back here to draw our object. So we'll have this kind of, so they'll hit the ray like that. Then our object will be called, sorry, and do that. To have that color. So this is the object, very dark object that will be formed here. To be formed on the screen, same size. Actually, they're supposed to be of the same size because there is no magnification. You can see. I don't know whether I can be able to draw some, to use some arrows, to use some dotted lines. I think I can use some dotted lines here. I want to use some dotted lines. Sorry. So dotted lines here. Hapa kuna dotted line. These lines in straight, Those are straight lines. So here is where we have our screen. Our screen is extending like this, like that, in that direction. So that is forming on a screen like that. So that's how the image is formed. The shadow, this is the shadow. The shadow is very dark. It's called umbra. So the shadow is very dark, formed, and it's called umbra. A very dark shadow is called umbra for a point source. So anytime a point source forms one shadow, which is dark, so shadows formed when an opaque object is on the path of light. The types of shadow formed depends on the size of the source of light, the size of the opaque object, and the distance between the so LB, the shadow formed, andika, ngoja kwanza, just write this, a uniformly and totally dark shadow is seen on the screen. I want you to write that. Andika, a uniformly and totally dark totally dark shadow into bracket umbra. Seen the screen, on the screen. Uniformly a dark shadow is formed or is seen on the screen. NB hapo chini, right? Note that NB, that shadows formed or shadows are formed when an opaque object is on the path of light. Shadows are formed when an opaque object. Shadows are formed when an opaque object. Example, we have formed one type of shadow. They are called facilitated. Right, that the type of shadow formed depends on the types, or the type of shadow formed depends on the type of shadow formed depends on what one. We have somebody called techno here in form 2. Kuna mtu kama techno kweli? Okay, atainua mkono tena tutamuona. If you raise your hand, I'll give you an opportunity to ask a question. So the type of shadow formed depends on one, the size of the source of light. So the size of the source of light, like if the source of light is so big, the type of shadow formed will be affected. So you either form umbra. So if the source of light is small, you form umbra. If the source of light is big, you form two shadows, umbra and penumbra. Hiyo tutaona tu saa hii tu. Then the other one, the size of the opaque object. The size of the opaque object. The size of the opaque object. Then the other one is the distance between the object and the source of light. The distance between the object and the source of light. The distance between the object and the source of light. I want to demonstrate something here. I don't know whether it will be visible to you. Kama inaonekana. Taona tu. Let's see. Nataka nione kama itaona. I have the earth here. Niko na earth. This earth, if I use a small source of light, which will behave like a point source of light, niko na earth hapa. So nataka nimulike. There's something I want you to understand. So if it's dark, I'm assuming there's a lot of darkness. This is a source of light. So if the source of light is so small, like this, if you're pointing this, normally I point heavy. So so this, you can see, there's no light that is through, or there's no light that is reaching this edge. Hakuna light inafika huku mwisho. All the light has been blocked. So naona hiyo light yote imekuwa blocked. There's no single ray of light that is passing to the other towards these ends. So all the light has been blocked. So do you expect to form what kind of a shadow do you expect on the other end? A dark shadow or a shadow that is having umbra and penumbra? Dark one? Any guess? Or any shadows. One, the first shadow is when you have a very dark shadow called umbra. Then the second type is when you have two types of shadows, umbra and penumbra combined. Two shadows, umbra and penumbra. Okay, when I use this source of light, you can see this source of light. The other end, I'll be having a shadow formed there. So you have only one shadow called umbra because there is no light that is passing on the ends of that shadow. I want to take another one. This one, you can see this pen, and you can see the source of light. This source of light is this object is very small, so there's a lot of light that is passing through the ends, through the ends. This side there is light, na pande ingine bado kuna light passing through, meaning that there is a lot of light that is passing on the ends. Therefore, they will be forming a shadow. If I have this, I have a shadow forming there. So if I have a shadow forming, I don't know. Let me try to. We have that pen there. Can you see a shadow that is forming there? That shadow has got two layers. A very dark one in, a dark shadow, and another shadow outside, which is faint. The faint one is penumbra. The dark one at the center is umbra. So we only experience this when you have a type of light called extended source of light. Extended source of light. Extended. I'll explain that again later. I'll explain that later. So let's see. Andika. Write this. So let's go to the second type of source of light. Andika extended source. Shadow formation by extended source of light. Andika hiyo. Shadow formation by extended source of light. Shadow formation by extended source of light. Shadow formation by extended source of light. Ernest. You're raising your hand up. Ernest amepotea. Unaweza inua mkono tena? That I can locate you. Ernest? Okay. Ernest ameogopa. So, andika shadow formation by extended source of light. If you have a question, ask anytime. Shadow formation by extended source of light. Andika shadow shadow formation by extended source of light. Extended source. So I want you to see how an extended source of light behaves. How an extended source of light behaves. It behaves like this. And I'll form this extended source. I'll have a source of light here. I want you to know the difference between a point source and an extended source. There you go. My source of light is there. So I want to have some bigger space here, some bigger allowance of that source of light. You can see that is there is more space, so there is more light coming out of that point. Then I have an object here, an opaque object. I want to have it here. My object is here. Then I have a screen here. I have a screen. I have a screen here. A very big screen. I want to extend my screen. My screen is like this. So I'll have two. I want you to be very keen here. Angalia vile ina behave. Sorry. I want to undo that. But I can use arrows. Actually, I can use this kind of arrows. So this is the first arrow. It goes like this. It hits the. It hits the. No, let me start with this. The first arrow will go like this. The first arrow will go like this. No. Let me just will hit the screen like that. And the second arrow will also hit the screen like that. That's the first one. That one will help us form what we call umbra. So then we have another one, crisscrossing. Sorry, should start from a common point. Should start from a common point. Zina crisscross come like this. You can see the difference between a point source and an extended source. Point source hakuna crisscross hivi. Then the other one is like this. To hit the mirror like that. So, in so doing, we're going to form two types of shadows. There is a shadow here that will be formed. One of the shadow here will be formed like this. Like this. Tumia moja ni very dark. There's one shadow that will be formed here, very dark. Like this. I want to undo. This should be that size. Very dark. That is faint. It's not that dark. Another shadow will be formed. And should be dark. There's another shadow there formed called umbra. So that's the shadow. So if I so I want to draw like this. So that's the two, those are the two that are normal formed. And I can do this. I want to draw some dotted lines here to show how it is formed. These are my lines that we formed in the screen. These are just to show, they're just meant to show the shadow is coming to the screen. So that is how they are formed. So that is how the shadow is formed. Umbra, this is called umbra. This is umbra. The dark one is umbra, ingine ni penumbra. So I want to write this umbra. Is umbra. Is penumbra. This one is umbra. The dark one is umbra. The dark one is umbra. The faint one is penumbra. Okay. Point source and extended source of light. So those are the two types of rays that we expect to see. Those types, the two types of shadows that we expect to see. Okay. I want to give you an assignment in the process. Everyone is having an access to the internet. So these things are normally shown very clearly in the internet. From this concept of umbra and penumbra, I want you to go to the internet and search this. When do andika mahali so that you can search the right thing. You go and watch these videos from the internet. Ya kwanza, when they watch, kitu inaitwa andika faces of the moon. Andika hii, so that you can go and watch direct from the internet. That I can have a few calculations with you. Andika faces of the moon. Alafu search, ukimaliza kuona hiyo, uone kitu inaitwa solar eclipse. The solar eclipse. The solar eclipse. Or eclipse of the sun. Or eclipse of the sun. You pia check. Kutoka hapo, you check, you watch another one here. You'll be able to see those videos. One annular eclipse. Under this, you see the annular eclipse. Then finally, after doing that, one inaitwa lunar eclipse or eclipse of the moon. One lunar eclipse. Stroke or eclipse of the moon. Hizo uone, you make sure that you watch those videos. Go to the internet, YouTube. Actually, you go to YouTube, specifically YouTube, and watch those videos. Once you're done with that, you'll be able to differentiate to see how now that concept of points of like when you have the moon between the sun and the earth. The moon is sun at that particular time will be because there is more light that is passing. When the moon is between the surface of the earth. One, there are some parts when you have parts are very dark, completely dark. So we have total eclipse, and other which don't experience total eclipse, they have a shadow that is called penumbra. But the ones that are experiencing that is called what? Umbra. So if you're at that region where we have the umbra, you have total eclipse. If you're in the region where we have the penumbra, you have a faint or a semi-eclipse where there is no much darkness. So if you go and watch that, you'll have sorted that issue out. I know you have access to internet because everyone here is having that access. So that's an assignment I've given already, so that I can have an opportunity of solving a question using a pinhole camera. Pinhole camera. Because I have a few minutes to go. So nataka tuandike chap chap pinhole camera. Andika pinhole camera. Pinhole camera. Pinhole. That is where now we get some calculation questions. The pinhole camera. Andika the pinhole camera. The pinhole. Pinhole camera. Pinhole camera is a camera with a hole, just like the word suggests. It has a hole size of a pin. A camera has got a very small hole, size of what? Size of a pin, a very small hole. So if I draw a pinhole camera here, I can just draw a pinhole camera here. A simple one, a very simple pinhole camera. Here it is, a pinhole camera. Nataka nikuchore moja hapa. Just a box. I know some of you have made it. Alafu, it's on a very small hole, size of a pin. A very small hole, size of a pin. A very small hole here. The hole has become very small. Yeah, that's a very small hole. Then there's some people who have raised their hands. Somebody? Nani ameinua mkono? Unaweza inua tena so that I can trace you. If you have a question, you can simply raise up your hand. So here we have a screen back here. We have a screen here. We have a screen at this point. Need a screen. So that's a screen at the back. Then you have the pinhole. Just that. Hakuna kitu ingine. There's a screen. I know you have made it. Umetengeneza hiyo kitu sana. So I can have these. Let me just write here. And write screen here. There's a screen. Then I also have something else here called, there's a pinhole. Yeah, and pinhole, a hole size of a pin, That's a pinhole. Pin. Then I want to have an object here. This concept is very important. So I want us to do within the few minutes we are having, tutaweza kumaliza. We'll be able to clear. I want to have an object here. An object. So in this concept of pinhole camera, we have what we call image distance, object distance, and we have the idea of magnification. So I want to list all what we need, and we know how to trace them in a pinhole camera. So this is what we need. We need one. We need object distance. We need object distance. We also need image distance. We also need object height. And we also need image height. We also need image height. So those are the things we need. How do we trace them in a pinhole camera? This one here, can you see this part, this region? This will give us, this part from here. The length of this camera will give us image distance. Here, it will give us image distance. So this will give us image distance. So before then, let me just show you what we normally form. I can have a small object. So that they can fit in our camera. Now here we do this. This is how we form the image. Remember the characteristics of the image formed. One, it should be upside down. See there? Should be formed upside down. And any arrow that we are representing, remember, it must have an arrow. The next one is here. So the image formed here will be upside down. It will be upside down like this. I can use a different color here to show my image. So this is the image. So this is the image. So this will give us image height. So this is the object height. Object height. So this length from where the object is all the way to where camera is what we call the object. And do that. We call this object distance. Object distance. So after knowing all those points, you can now simply go to the formula that we normally use in a pinhole camera, and the formula goes like this. It says, normally say, the formula is, after now understanding all those object distance tuko nayo, image distance, object height tuko nayo. So tunasemanga object, we normally say in a pinhole camera, we use a very simple formula. Object distance, so magnification is equal to, so we say that image height, this is image height over object height is equal to object height, no, image distance. Distance nimekuonyesha ni gani? So utasema image distance of object distance, which is also equal to magnification. Somebody is raising the hand. Martin, you're saying something? Martin, you're saying something. Karani. Martin Karani. Is equal to magni. Is equal to magnification. So after understanding all that, we can do a question. So I want us to use up to 10:25. I give you 5 minutes to ask any question that you want. So nataka an object. I want us to write this. Try this question. The question is here, only one here. An object of 85 meters. An object. Martin Karani, nimekupatia nafasi hujauliza swali. You have not unmuted. So the same. Andika hii. An object of 85 meters is placed 10 meters away from a pinhole camera. An object of 85 meters. An object of 85 meters is placed 10 meters away from a pinhole camera. Calculate. Calculate. It's placed away from the pinhole camera. Calculate the size of the image if the magnification is 0.01. Calculate the size of the image, or else you can write calculate the image height if its magnification is 0.01. If its magnification is 0.01. If its magnification is 0.01. Or there's somebody asking, is the image magnified or diminished? This image that you have in here, it can be diminished, it can be magnified. Oh, somebody is telling meters is placed 10 meters away from a pinhole camera. An object of 85 meters is placed 10 meters away from the pinhole camera. Sio ni object distance. 10 meters itakuwa object distance. Na object height itakuwa 5 meters. Calculate the size of the image if its magnification is 0.01. Size of the image if its magnification is 0.01. B of the question, the length of the pinhole camera. The length of the pinhole camera. Hiyo ni image distance. Pardon. Hiyo ni Gideon, Simon. Lemi Mundia. Is the question clear? Or I can write the question here again. Namjua masaa imeenda. Your nini had said I'll give you 5 minutes, and you can see our time is. Somebody with an answer? So nataka kuandika hii swali hapa. In case the somebody was not under nini. Tunasema sema an object of height 5 meters is placed is placed 10 meters away, from a pinhole, from a pinhole camera. Calculate the size of the image, if magnification is 0.01. B, the length of the pinhole camera. The length of the pinhole camera. So I want to go to the solution very fast because of time. Ama mshamaliza? I want to go to the solution very fast. So utaandika what you're supposed to cover here, or what you're supposed to get, part A is magnification. Magnification is equal to, tushaandika hiyo, magnification is equal to height of the image over height of the object. So therefore 0.01 is equal to height of the image, or G, 0.01 over what? Over 5. So therefore height of the image is equal to, we multiply by 5 times 5. So it's equal to 5 times 0.01 to get 0.05 meters or 5 centimeters. So length of the pinhole camera, part B, that should be the length of that should be the image distance. As you can see, I've just explained that nikichora hiyo diagram. The image distance is the length of that camera. Therefore, image distance over object distance is equal to magnification again. So you can either use image distance of object. Okay, you can use that formula quickly. So 0.01 is equal to, I'll do image distance. So you can say, write image distance over object distance is given as 10. And multiply by 10 there, times 10 there, to get 0.1 meter is equal to image distance, or 0.1 meters or 10 centimeters. 0.1 meters or 10 centimeters. So I know our time cannot be enough to cover everything. If somebody is having a question, you can simply ask the question. Kuna mtu akona swali? Mulumba, raise up your voice. Mbona sikusikii? Unmute yourself.
Ukiulizwa useme property that is suggested when shadows are formed. You talk about the rectilinear propagation of light.
Properties of images formed in a pinhole camera. 1, they are upside down or inverted. The other property is that they are real. A real image is always formed on a screen, right?
Yes. My question is, if you are told to suggest the property shown by formation of shadows, what do you talk
Yeah,
about?
it is that is the electrical propagation of light, whereby we say that light travels in a straight line. That is the one that makes, that's the one that allows what? It allows, it facilitates formation of shadows because light cannot bend. It will hit the obstacle and form a shadow at the back.
Thank
Jackson. Okay, welcome. Jackson? No. Jackson?
Niko sawa. I am okay.
Bado unacheza football?
Yes.
Unachezea wapi siku hizi?
Hapa tu around.
Bado unawafunga? Sawa. Na Newton? Newton?
Yes.
Unafanya kazi gani nyumbani?
Kucheza kiasi na na quarantine tu.
Na 1 meter unachezaje kukiwa na 1 meter? Social distance nayo unacheza aje kukiwa na 1 meter?
Of course I'm following the directives. Your social distance pia naifollow.
Directives. Mimi kangebe. Smith.
Yes.
Bado unasoma? Mpaka kazi yako ni kujificha tu. Kuna Brixton. Brixton. Brixton ako kweli? We also have, and otherwise, I hope you are going to do that. Remember what I've told you. You go to YouTube, you watch those things I've told you. Usiende YouTube kuona vitu zako. Najua zile vitu mnaenda kuona huko. You just go and watch what I've told you.
Yes.
Usiende kuona vitu zenu hapo. So the assignment I've given is very simple and very enjoyable. You go and watch those there are those videos, air clips. Uone, ukisikia watu wanasema kuna air clips, watu wanakimbia kuona, you can explain what is happening. Sawa? Usikuwe kazi yako ni kwenda tu unasikia watu wanasema air clips and you cannot explain to anybody what that air clip is. So you need to have the real understanding of that air clip. Sawa? Otherwise, have a good weekend. Lesson over. Sawa? Lesson is over. Unless somebody has a question. Kuna swali? So you're okay, all of you? So we can end our meeting. We can end our class at that point. Have yourself a good weekend.